informasi selanjutnya, kasus positif virus corona di Indonesia tembus 200.000.
10 September 2020, penambahan kasus COVID-19 di Indonesia menjadi yang terbanyak sejak pertama kali dilaporkan.
Total kasus positif virus corona menjadi 311.176 orang.
Kematian akibat COVID-19 disebabkan lantaran pasien memiliki penyakit penyerta. Di antaranya penyakit penyerta tersebut yang tertinggi adalah diabetes dan juga hipertensi.
The number of positive cases of COVID-19 in Indonesia, which counted until 12 January 2021, has claimed more than 800,000 patients, with the death cases up to 24,000 patients. From the total number of deaths, diabetes mellitus was ranked second as a comorbid disease with 9.5%, while hypertension occupies the first rank. Diabetes mellitus, especially type 2, is a non-communicable disease characterized by high blood glucose levels. The disease, which is called the silent killer, can affect all body organs and cause various other diseases. It can even worsen the condition of COVID-19 patients. Diabetes mellitus is mostly caused by unhealthy lifestyle, such as high daily sugar intake. So, one simple step to prevent diabetes mellitus is maintaining daily sugar intake, according to the recommendation of World Health Organization and the Indonesian Ministry of Health Regulation, which is 50 grams per day. However, the results of statistical tests show that the average person's sugar consumption from sweetened drinks is 60.43 grams per day. This is because the products on the market, especially sweetened drinks, have sugar contents around 37 to 54 grams for a size of 300 until 500 milliliters. Of course, this is against the recommended maximum sugar consumption limit for an individual. Therefore, we are Parakarta Team from Gadjah Mada University create an innovation that can monitor one's daily sugar intake effectively and efficiently, which is called GLUCAS. The system consists of smart tumbler that is integrated with smartphone application via Bluetooth to track sugar consumed easily. The study aims to create a smart tumbler design that uses an interdigitated electrode-based sensor to detect sugar levels that is integrated with smartphone application via Bluetooth to easily monitor daily sugar intake.
The first method of establishing this innovation is collecting research materials through literature studies, then determining the purpose and design the smart tumbler and smartphone application. The design of the smart tumbler and smartphone application is shown on the slide. The inside of the smart tumbler is designed to use BPA-free aluminum to meet food-grade quality. Since the total sugar mass depends on the amount of the beverage, it is necessary to multiply the detected sugar level by the liquid volume. This tumbler is equipped with an ultrasonic sensor to measure the height of the drink to obtain the volume. The detected sugar mass information is then sent to the smartphone application via Bluetooth to be accumulated with the data that has been recorded in one day. To detect the sugar level itself, we choose an interdigitated electrode as the sensing element, which will be placed at the bottom of the tumbler. IDE's advantages are its relatively small area, simple sensor configuration, reachable, and fast response. Based on literature studies, the method used for IDE fabrication is photolithography, a superior and a standardized way with a micrometer order on fabrication resolution. The geometry of the IDE is shown on the slide. For IDE to accurately detect sugar levels, it is necessary to coat a compound that is only sensitive to sugar. At this writing, a non-enzyme coating material is chosen in the form of a molecularly imprinted polymer. Glucose, which binds to the coating material, will change the value of the sensor capacitance. As a result, the sensor output voltage changes and can be acquired by the microcontroller system. Here is GLUCAS system diagram. First, the user pours the beverage into the smart tumbler. Two sensors will then measure it with an ultrasonic sensor measuring the beverage height and an IDE sensor measuring glucose concentration. After that, data from the sensor will be calculated in a Node MCU ESP32 and send the results to the smartphone via Bluetooth. Finally, glucose mass will be displayed in the app as sugar intake. There are 3 indicators in the app. Green means daily sugar intake is still okay. Orange means users need to be careful of their daily sugar intake. And red means sugar intake is above the limit and it is not good for health. Then, sensor testing is conducted to determine its characteristics. Based on the literature study, the IDE analysis coded by molecularly imprinted polymer needs to be compared with IDE coded by non-imprinted polymer or NIP. From the test results, the MIP1 has high sensitivity. The sensor shows a signal change from 99.9 nanofarad to 393 nanofarad against 1 to 50 ppm, which shows linearity that depends on the glucose concentration. Meanwhile, the NIP1 was not at all influenced by the change in concentration. Based on the test, it was also found that the IDE coded by MIP had high selectivity to glucose molecules, so that the other materials in the beverage would not interfere with the measurement. All of these give the IDE sensor 98.6% accuracy. In addition, the IDE sensor also has high stability and durability. This is shown from the tests carried out for 1 year, so that the smart tumbler can be a durable quality product.
Based on our financial projections, it's needed about 75 million rupiahs for the initial capital. It's planned to sell as many as 85 units per month with an estimated price of 700 to 800,000 rupiahs, resulting in an annual net income of around 51 million rupiahs. In the future, the source of funds for manufacturing can be obtained from universities, health or food companies, or also government agencies. GLUCAS has enormous potentials. This smart tumbler can calculate the mass dissolved in the beverage accurately to help someone control sugar intake effectively and efficiently. In addition, the smart tumbler can reduce the number of diabetes mellitus and prevent other complication disease. It can also help Indonesia achieve third point of sustainable development goals and support in creating a healthy society. Therefore, it's concluded that GLUCAS is a practical system for monitoring daily sugar intake to reduce the risk of diabetes mellitus and various other diseases. The high sensitivity, high selectivity, and high sensor stability make GLUCAS certain a quality and be a durable smart tumbler. Reliable price estimates and user-friendly operating system make GLUCAS as a good investment for health and can be used by all ages. The last, it's hoped that GLUCAS can reduce the death rate of COVID-19 patients and promote public health, especially during the new normal era. This is the end of our presentation. We believe this innovation can be useful in the pandemic era and beyond. We are so sorry if we had a mistake, and thank you very much.